Hey everyone, welcome to another video. This video is going to be very short and very straight to the point. It's going to be 3 questions about related rates. Question 1. A spherical object is expanding with a radius increasing at a rate of 40 meters per second. Find the increased rate of the volume and surface area of this object given that the radius is 10 meters. Now, the first thing that you have to understand is that the volume has a formula of 4 over 3 pi r cubed, and the surface area has a formula of pi r squared. Now, second. All right, so these two formulas are the main formulas we're going to use to solve this problem over here. So the first thing that we're going to do is basically we're going to derive both the volume and the surface area to find the rate. So over here, we're going to find the rate of the volume first. So dV over dt, it is going to be 4 over 3. The 3 is going to drop down, so that's another 3 here. Pi r squared multiplied by dr over dt. Now, the 3 and the 3 are going to cross each other out, and r is basically 10. So 4 multiplied by pi multiplied by 10 to the power of 2 dr. Oh, and dr over dt is basically 40. So 10 to the power of 2 is going to be 100. 100 times 4 is going to be 400. And then 400 multiplied by 40 is going to be 16,000. So dV over dt is going to be 16,000. The unit is basically meter cubed per second. Why is it cubed? Because we're talking about volume over here. All right, so once again, we write the formula, we derive the formula, we put the given numbers in the formula, and then we get the value for the rate of the volume. Similarly, for the surface area over here, dA over dt, the 2 is going to drop down, so it's going to be 4, 2, pi r multiplied by dr over dt. So the r again is 10, so 4 multiplied by 2 multiplied by pi, 10, and dr is basically 40. So 2 times 4 is going to be 8, 8 times 10 is going to be 80, and then 80 multiplied by 40 is going to be 3,200. So 3,200 pi meter. Oh, over here we got the pi over here. So pi meter squared per second. So don't forget to put the pi in. So this one is squared because we're talking about area, and this one is cubed because we're talking about volume. And this is it for question number 1. In question number 2, a kid marked the top tip of his 25 centimeter ruler and laid it back against the wall. So basically we have a wall, and then the ruler, let's say that the ruler is like this. It's laid back against the wall. And he marked the top tip of his 25 centimeter ruler. So he marked it from the top. And this ruler is 25 centimeter. Soon the ruler started slipping away from the wall. So the key word over here is the word away. So that means that the distance over here, it's slipping away from the wall. So you notice how a ruler, when it falls, it's gonna flatten out as such. So over here, it's slipping away from the wall at a rate of 3 centimeter per second. So I'm gonna call this dx over dt 3 centimeter per second. The question is, find the rate of the top tip slipping down at the moment the base was 8 centimeter. So basically over here, the base is 8 centimeter. Okay, and they want me to find the rate that it's falling down. So I'm gonna find dy over dt over here. Now this is a right triangle. So using Pythagoras theorem, first of all, let's find y, which is like at the moment the base was 8 centimeter, What is y? So basically what I'm going to do, I'm going to find 25 to the power of 2 is equal to 8 to the power of 2 plus y to the power of 2. That means y to the power of 2 is going to be 25 to the power of 2 minus 8 to the power of 2. So 25 to the power of 2 is basically 625, and we're gonna minus that with 64, which is going to be 561. So the square root of 561 is going to be 23.68. So y in this case is going to be 23.68. What's the unit over here? Centimeter. Now we're done with the first part. Okay? Now, the hypotenuse is literally the same. It's 25. Okay? If the ruler is going to fall down, the hypotenuse is going to remain the same because the ruler's height is not changing. So 25 to the power of 2 is equal to x to the power of 2 plus y to the power of 2. Why did I write x over here and y over here? Because now I want to find dy over dt. So the thing is, the 25 does not change because the ruler's height does not change. However, the side over here is changing and the side over here is changing because this one is getting shorter and this one is getting longer. However, the hypotenuse remains the same because 25 centimeter remains 25 centimeter. So if I'm going to derive this, 25 to the power of 2 is going to be 0 because it's a constant. And this is going to be 2x dx over dt plus 2y dy over dt. Now replacing the variables with their proper values, x is basically 8, so 2 multiplied by 8 dx is basically 3 centimeters plus 2y is 23.8 dy over dt. Now 2 times 3 is going to be 6, 6 times 8 is going to be 48, so it's going to be negative 48 equals 2 times 23.8, which is going to be 1 second times 2, which is going to be 47.37. So 47.37 dy over dt. That means dy over dt is negative 48 over 47.37 centimeter per second. Now, it makes sense that dy over dt is negative because the distance over here is getting shorter. And since the distance is decreasing, that means the rate is going to be negative. Now, the final question over here, question number 3. Ship A is moving west towards location A at a speed of 20 kilometers per hour. Ship B is moving north away from location A at a speed of 23 kilometers per hour. Let A be the distance between ship A and location A. Let B be the distance between ship B and location A. Sketch the problem. So first things first, location A, let's say it's over here. Okay? And now let's say that ship A is over here and ship B is over here. Now they're telling me that ship A is moving west towards location A. So it's moving west towards location A at a speed of 20 kilometers per hour. We're going to call it let's call it dx. 20 kilometers per hour. And they said that ship B is moving away from location A to the north. So it's moving north away like this. And the speed over here, we're going to call it dy over dt. We're going to call it, with dy over dt, it's basically 23 kilometers per hour. So then they said, let A be the distance between ship A and location A. Oh, if that's the case, so let me just change x and y. Let me change them to A and B. So this is going to be dA over dt, and let this be dB over dt. So A is basically the distance over here. So that is A. And the distance between B and location A, that's going to be B. And this is going to create also a right triangle, as you can see over here. So find the distance between the two ships given that A is equal to 16 and B is equal to 25. A very straight to the point Pythagoras question over here. So the distance between the two ships are going to be, let's call this C. So C squared is equal to A squared plus B squared. So that means C squared is equal to 16 to the power of 2 plus 25 to the power of 2. So that means, okay, which is going to be 881. So the square root of 881 is going to be 29.6. So we're going to round it up to 30. What's the unit over here? Kilometers. And the last question over here, they said, find the rate of this previous distance. So since I was saying that C squared is equal to A squared plus B squared, now here's the difference. In the previous question, you notice that the ruler was not changing the hypotenuse length, which was 25. Therefore, the derivative for it was 0. However, over here, it's a different scenario. Why? Because ship A is moving at a speed different from ship B. If they were moving at the same exact speed, the hypotenuse would have been the same. However, since they are moving in different speeds, that means the hypotenuse is changing. So over here, the derivative of C squared is equal to A squared plus B squared. This is going to be 2C dC over dt, 2A dA over dt, plus 2B dB over dt. And we're just going to replace every single number with its proper value. So this is going to be 2. What is C? It's 30 dC over dt. 2. What is A? 16. What is dA? 20. Plus 2. What is B? 25. And what is dB over dt? It is basically 23. So give me some time to plug this in on a calculator. So 2 times 16 times 20 plus 2 times 25 times 23, which is going to be 1,790. So all of this is going to be 1,790. And 2 times 30 is going to be 60 dC over dt. Therefore, dC over dt is going to be 1,790. 1,790 divided by 60. So it's going to be 29.83, or we can just round it up again to 30 kilometers per hour, because the rate over here is per hour, so you have to make sure that you're writing it per hour. So this is it, guys, for today's video. If you have any questions, please leave it in the comments, and thank you so much.